Hi, I'm an old guy and I do maths. We have to find solutions for this equation. 2 sine 2 into x minus pi on 4 equals root 3. And our domain is between negative pi and pi, inclusive. So let's go to work. Predominantly this is a game of algebra. We will at some point resort to circular trigonometry, but principally, other than finding the value of the sine to start with, it's mostly algebra. So here we go. Sine 2 into x minus pi on 4 is equal to root 3 on 2. Now, the little bit of circular trigonometry to be going on with, badly drawn triangle, that's a right angle. That is root 3, that is 1, that is 2. These should be familiar. This is pi on 6 up here, and this is pi on 3 down here. Now the sine of this is equal to that. So the sine is the opposite over the hypotenuse. We're looking at this angle. So we can replace the sine and this with this value in radians. So we have 2 into x minus pi on 4 is equal to pi on 3. I hope that made sense. Essentially what we've done is we've replaced that with this. We've found what the value corresponds to in terms of radians. Now we're back to algebra. So what that means is that x minus pi on 4, if we want to get rid of this 2, we divide both sides by 2. That gives us pi on 6. And again, I hope that's clear. If we want to divide this fraction here by 2, we double the denominator. Nothing terribly complicated about that. So x is equal to pi on 6 plus pi on 4. We're playing with fractions. 6 fours are 24. 6 ones are 6 pi. 4 ones are 4 pi. There we go. So that is 10 pi on 24, which is 5 pi on 12. Okay. Now, we found a value for this. We need to check about other values. So, the next thing that we do is we resort to our old friend, the unit circle. Now 5 pi on 12 is up here somewhere, round about there. We don't have to be precise. And the value of the angle is this. So over here, because sines are positive in the second quadrant, we have a corresponding angle. And if that is 5 pi on 12, that is 6 pi on 12, that is going to be 7 pi on 12. So 5 pi on 12 there, 7 pi on 12 there. Sines are positive here and here. These, if you pop these in a calculator, you will get the same angle from the x-axis. From the x-axis, that's the important point. Okay, so far we have 5 pi on 12 and 7 pi on 12. We should check for something else. And again, just as this comes down to symmetry, I should make a note there. That's really what it is, it's just symmetry. If we move to graphing this on a Cartesian plane, And I'm not going to get into what the graph actually looks like, but let's say that this is pi and this is negative pi, which is the extent of our domain. What we know is that 5 pi is around here and 7 pi is around here. And let's just assume that this thing is a normal sine graph. There's no indication that it's not, that there's anything strange about it. So basically what it's likely to do is something like that. Just excuse my drawing. We're going to have some solutions over here. And by symmetry, we can say that this is going to be negative 5 pi on 12, and that's going to be negative 7 pi on 12. So I think we have 4 solutions for this. Negative 5 pi on 12 can go in there, and negative 7 pi on 12 can go in there. So just to recap and to explain a little further, this function is going to have a period of 1 pi. Now that is because this 2 will multiply the x and we'll have sine 2x, if we just ignore this for the moment. So the period of a sine graph is going to equal 2 pi on n. Now 2 here is the n, so that's 2 pi on 2, which is equal to pi. Now if we come down here, I'll just explain this business of symmetry. So if this is 7 pi on 12 and this is 5 pi on 12, and we've got some sort of symmetric graph, which we do because it's a sine graph, and we know that the period is 1 pi, if we subtract 1 pi from this, 5 pi on 12, we get all the way back to here, negative 7 pi on 12. If we subtract 1 pi from this, we get all the way back to negative 5 pi on 12, That is why this looks like it does. This is why these are the 4 solutions within that domain. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.